Discuss about Monte Carlo simulation technique before we go to use the crystal ball software as the core or the main principle of the crystal ball based on the Monte Carlo simulation technique. Monte Carlo based on the Monte Carlo in Las Vegas in early 19th century they start professor to make some probabilistics which is Monte Carlo to be used for the Las Vegas for the work with paper with money and so on, and then it will be very secret when this technique can be used in World War II, and then it will be popular for to be used anywhere. Here you can see if you have two parameters, we have A and B, and this is a simple equation: A plus B equal X. B plus B equal X. Simple equation. Variable number A, variable number B, and then it will be the outcomes. This is the outcomes. As it will be red, green color, which is input data, the variables. Every variables we have, it will be presented as we will see in the crystal ball by probabilistic distributions. Whatever you selected, it will be normal distribution, log normal distributions, beta, gamma, geometric, Weibull distribution, whatever the distribution. Okay. And the another factor, it will be another distributions according to the parameters. And before, for the probabilistic distributions session, we discussed that every parameter have its characteristic, have best distribution match with its characteristic. As we discussed, the heights of the persons, the employee, normal distribution. Concrete strength, example, normal distribution. We mentioned about the traffic and something, it will be Poisson distribution, and so on. Okay, and also we have the data, we have the mean, we have the average, we have the standard deviations, all the data to be applied. So we have the data, this is just the number, it will be the first one. So this number, maybe it will be the average or not the average in the cell existing. But anyway, for any variables, it will be presented by the distribution, probability distribution function, and it will be presented by the average and the standard deviation, maybe the location with the shaping according to the distribution as we discussed before. And then he makes a summation. What happened exactly? He used a random number. Or you can remember here we have in the calculator we have some called a random number. Okay, what is random number? Just in the old history they use some book. This book have a lot of numbers. Then they book any page random and then select one of and short close his eyes and choose any number as random. Okay, now for the calculator we use it. It will be the same like Excel sheet. What happened exactly? He have a random number. We can put some number here like called the first one in the crystal. You can define it or you cannot define it. Here assume it will be 5 digit or be 5555 called the seed number. You can see it in the crystal ball that you have an option to put the seed number. What we do here? He makes this number and it will be 5 5 5 5 and then takes the square for it. When he takes the square, he makes this number. What he use? He delete this number, the middle number, and he takes this number together. So the first random number, it will be 3025, and then 3025 takes this number and make it square. You can find it will be this number. So we remove the middle and it takes the end one and the end one. So the second number it will be 9125 and so on. And repeat it. Okay, this is done. This is done. So at every random number here, it will be divided by 10,000 because we have 10 digits. So it will be 0.3025, and the next one it will be 0.9125. So this number cannot be more than 1. So any random number when divided by 10,000 should be less than 1. Less than or equal band, but when it will be equal 1, it will be probability, it will be very minor, very minor. Okay, in any way it will be less than 1. Okay, so what the software he will do, he make a random number for every variables. So he make the trial 1, you make a random number for this, so it will be, for example, 15. He makes a random number, so we have RND1 for trial 1 and RND for variable B trial 1, and so on. What about after he obtains a random number? He goes through this curve. You can remember this curve. This is the relation between the concrete strength and the probability. Here it will be the maximum, it will be 100. It can be also from 0 to 1. So can be represented by 100 or can be represented by 1. And they have this diagonal. Okay. So assume the first variable, it will be concrete strength. When you have the random number, the first random number 3025. So I take 30.25. If I decided that the maximum number, it will be 100. If it will be 1, so it will be 0.325. It will be the same. But anyways, the probability, the maximum probability, it will be 1. Okay, the area under the curve, it will be 1. So from this random number here, because it will be 45 degree, so it will be the same. It will be the same here. Okay, 30.25. Go to the curve, obtain this number. What this number provide us FVC dash equal, for example, 320, 340, 330. Assume this number is 330. This for random number 1. So this random number 1 provide us this value. Then he make another random number. The other number was what? I think 9125. 9125. Here, sorry, 91.25. So we go through 91.25 here. Then go through this curve, then obtain the corresponding value. Here it will be 410. So it will be corresponding to random number 2. From where this curve, I mentioned to you that every variable we already define on the input here about its probability distribution, as I mentioned. So every one from this variable have its probability distribution. So I make random number 1, so it will be provide me trial 1, so it will be A1, and I have already random number 1, the same another random number, so for variable B, and it will be B1. The summation, it will be X1, and then repeat it again, A2, B2, so we have X2, and so on, until we have a lot of trial. As we mentioned, for the example, we have 10,000 trial. So I have X until 10,000 numbers. Okay. So this is the target of the Monte Carlo simulations. Okay, so after we make this, we make summation. What's mean here? Like the test, every variables, maybe in some cases it will be high value A, the another value it will be low. This one case, maybe another random number, it will be medium, here it will be very low, here it will be high, and so on. All this alternative, like the test, I make the test every time I have another outcome according to the probability distributions. Okay, so at the end I have 10,000 outcomes can be obtained from this equation or from the case that I will be discussed about. This is the target of the main core of the Monte Carlo simulation technique. Okay, so if I choose the distribution variable wrong, so all the outcome it will be wrong. So the distribution should be selected very precise, what I need exactly, and also according to all the variables. So the outcomes I have a lot of data. Then I have this alternative variables. I have the curve for the x itself. Here I can define about the probability of this curve, and also I can make by the equation of statistics as I mentioned before according to chi-square or ks. We can define what about the best probability distribution can present the output x. You can make the data, so you have a standard deviation, you have the average, you have the coefficient of variations, any data, because I have a lot of data, so I need to make analysis of it, and then I can define what about the B10 هنا B90 B10 or B50. In case of the middle it will be B50 and so on. So B90 B10 I can be obtained as we will discuss in the crystal ball software. Okay, so I wish it will be clear for this about the core of the Monte Carlo simulation. It will be easy. It will be the concept can be applied for any software, but thanks a lot. And if you have any question or any inquiry, don't hesitate to contact me on our website, my email or my WhatsApp. Welcome anytime. Thanks a lot.